Imagination is more important than knowledge, for knowledge is limited to all that we know and understand, while imagination embraces the entire world and everything there will be to know and understand. Albert Einstein's words, though not unlike he, were genius. It is thanks to Erwin Schrödinger's knowledge that we have advanced as far as we have in the realm of quantum physics. His work helped us as a species understand the properties of the quantum phenomena and, in turn, the universe as a whole. With this in mind, I'm here today to help you get to know who this great man was and how he became great, what quantum physics is and how it differs from regular physics, and how he managed to explain the quantum phenomena known as superposition using his thought experiment today known as Schrödinger's cat. My goal for today is to have all of you walk out of this classroom with a clear and concise understanding of this famous thought experiment. According to the Erwin Schrödinger biographical by fellow physicist and friend Paul Dirac, the physicist began his fame behind the famous thought experiment, was born on August 12, 1887 in Vienna, Austria, as the only child of Father Rudolf Schrödinger. Erwin began his journey in the realm of physics at the University of Vienna, where he spent 4 years studying there. He graduated with a PhD in physics, according to Biography.com's article titled Erwin Schrödinger Biography. He stopped his studies to fight in the First World War as an artillery officer. After the war, he took up an academic position at the University of Zurich with fellow physicist Max Wein. He spent 6 years there doing research on the properties of quantum particles. According to the article, How Was Schrödinger's Cat Related to Quantum Physics?, the young physicist created his famous wave equation while working there. In 1927, he moved to Berlin. His draw to the city was due to the Renaissance-like rebirth of science, where he worked with others who, he said, exceeded him in age and reputation. During this time, his dissatisfaction with Bohr's orbital theory caused him to embark on a journey to describe the quantum condition of atomic spectra using a mathematical formula known as eigenvalues. His work garnered him and Dirac the Nobel Prize for Physics in 1933. Though, due to Hitler's coming to power in the same year, he moved to England and held fellowship at the University of Oxford. From there, he moved to Italy, and then to the Institute of Advanced Studies in Dublin, Ireland. He worked at the Institute as the director of the School for Theoretical Physics. He spent the rest of his career there until his retirement in 1955. When talking about Schrödinger and what Schrödinger studied, one may ask, what is quantum physics? According to the article Quantum Physics Overview, quantum physics, also known as quantum mechanics, is defined solely as the study of matter, energy, nuclear, molecular, and even smaller particles and how they interact with the world around us. What makes quantum physics so interesting is that these particles and molecules operate with a different set of fundamental laws than that of Newtonian physics. Most of the remaining questions that surround quantum physics revolve around the idea of superposition and how this quantum mechanical property affects everyday objects governed by Newtonian physics. Superposition, as stated by the article, What is Superposition?, on the website physics.org, is when a quantum particle is existing in all of its various states, such as wavelength, radioactivity, or even placement, all at once. In essence, a particle that is in superposition can be in both a wave or particle form and in a radioactive or passive state. Now you might ask, where does the cat fit into all of this? According to an article called Schrödinger's Cat Explained by Lisa Winter, Schrödinger created the paradox in 1935 to help demonstrate how the Copenhagen interpretation of quantum particles is flawed. Also, according to the National Geographic magazine article titled The Physics Behind Schrödinger's Cat, the paradox now has become a pop culture icon. According to Henry Reich's video Schrödinger's Cat, the thought experiment goes as such. You put a cat in a box with a radioactive quantum particle, a vial of poisonous gas, a Geiger counter, and a hammer mechanism that will break the vial at the detection of radioactive rays. Within a minute, there's a 50-50% chance that the vial will be broken. After the minute is up, we don't know whether or not the cat is dead or alive, and when we do look, the cat is either dead or alive. but not both. According to the quantum physical laws, before we look, the cat is in a superposition, and our act of looking forces nature to collapse into one reality or another. So, essentially, our curiosity kills the cat, making it a catastrophic outcome. But physicists are asking the question, who is observing us to have our realities collapse into one or the other? Or does it take a self-aware being to force nature's decision? Which then begs the other question, what does it mean to be self-aware? These questions have been pestering quantum physicists for years, and hopefully we will someday figure out these seemingly unanswerable riddles. Now, since you all hopefully know a thing or two about the famous 1930s thought experiment, you will no longer be confused by the endless Schrodinger's cat shirts and annoy people by asking them what they mean. I hope you've enjoyed learning about this man's life, work, and the help he brought to the world of quantum physics. His work has been an important part of finding out which questions we should be asking about the universe. For real, though, I hope you all learned something about this perfect thought experiment and go home with your mind opened by all the possibilities.